Today's topic is the Newton-Raphson method. Have you ever needed to find the root of a messy equation? Like where a curve hits the x-axis, but didn't have a neat algebraic solution? Well, that's where the Newton-Raphson method comes in. It's like a clever guess and check game that uses calculus to quickly zero in on an answer. Let's break it down step by step. Imagine you're standing on a hill, trying to find where the path leads back to sea level. You can't see the end, but you know the slope where you are. You use that slope to predict where the path might hit zero. That's exactly what the Newton-Raphson method does. It starts with a guess for the root of a function. It uses the slope at that point, and draws a straight line, or tangent. Then it sees where that line hits the x-axis. That point becomes your new guess. You do it again and again, and each time, you inch closer to the true root. It's simple, yet powerful. Now, here's the formula behind the method. To find the next guess, take your current guess, subtract the function value at that guess, and divide by the derivative at the same point. We use a first-order Taylor approximation near the current guess. We approximate the function like this. Solving for where this approximation equals 0, we get. Let's say we're trying to find the square root of 2. That means solving the equation. The derivative is. We start with a guess, like 2.5. Plug that into the formula, and we get a new, better guess. Repeat the process, and each time, we get closer to the actual square root of 2. So why does this method work so well? The secret lies in the tangent line. Each time, we approximate the curve with a straight line and solve that instead. Straight lines are easier to work with than curves. By solving where the tangent crosses the x-axis, we make progress with each step. If our initial guess is close enough to the actual root, this method can converge really fast. Sometimes, it only takes 3 or 4 iterations to get a super accurate answer. But the method isn't perfect. If the slope is 0 at your guess, you'll end up dividing by 0. If your guess is too far from the root, the method might head in the wrong direction. Some functions behave badly. They might flatten out or twist in ways that confuse the process. So a good initial guess is key. Just like using GPS, you need a good starting point to find your way. Where do we actually use this method? All over the place. Engineers use it to find stress points in materials. Economists use it to solve equations about supply and demand. In statistics, it's used for fitting models, especially in maximum likelihood estimation. Many machine learning algorithms also rely on it behind the scenes. It's a real-world tool that helps improve predictions in science, tech, and finance. Now let's try to picture it. You have a curve. You start at a point. A straight line touches the curve at that point, the tangent. You follow that line to the x-axis. That gives you your next guess. Repeat the process, and you watch your guess bounce closer and closer to the actual root. It's like dropping a marble down a ramp. Each bounce brings you closer to the bottom. And before long, you land right where you wanted to be. The interactive tool we introduced in this video is linked in the description, so make sure to check it out and have fun exploring it yourself. If you enjoyed the video, give it a thumbs up, and if you want more hands-on ways to learn stats, subscribe to the channel and hit the bell so you never miss a new drop. Thanks for watching, and remember, don't just think. Feel the stats.